Hello, pre-calc students, and welcome to another video on half-angle identities. This video should hopefully be very similar to like that day 2 video of sum and difference identities, in that I'm just delivering the information a different way. So we're practicing the same concepts, I'm just delivering the information to you in a different way. Alright, so before we get into that new way of delivering the information, we need to recall our half-angle rules or formulas, identities, whatever you want to call it. Alright, there's no way around it. They're kind of ugly. Alright, we know that if we have the sine of a half-angle, well, we know it's either going to be plus or minus, depending on where that half-angle lies, and it's going to be 1 minus the cosine of the full angle all over 2. And very similarly to that formula for the cosine half-angle, it is again plus or minus depending on where the half-angle lies, which quadrant and whatnot. But now we're doing 1 plus cosine of the full angle all over 2. Okay? So, of course, one nice trick that we have for finding tangent of a half-angle is just dividing the two by each other. And if I take sine over cosine, well, the 2's are going to cancel. I'm just going to have 1 minus cosine, 1 plus cosine underneath radicals. So I would have something like this. 1 minus cosine on top, 1 plus cosine on bottom, and that would work. But if you remember correctly, this isn't always the nicest way to think about this. This requires a little bit extra work. It's going to leave our answers a little bit sloppy. So what we were able to do is we were able to actually come up with 2 other ways, formulas, based on when we multiplied by conjugates. So if we multiplied by the conjugate of the numerator, 1 plus cosine, 1 plus cosine, well, that means that we would have 2 1 plus cosines in the denominator. And when you take the square root, that means you would have 1 plus cosine on the bottom. Well, we know that the whole reason for multiplying by the conjugate is that we can turn it into 1 minus cosine squared, and we know that 1 minus cosine squared is sine squared. And when we take the square root, we get our sine. The other way, I just want you to remember, like if you leave the 1 plus cosine in the bottom, well then it's sine's on top. If we leave the 1 minus cosine on top, then we'll get sine on the bottom. Okay, so both of these come directly from multiplying by the conjugates and then taking square roots when we had parts that were being squared. Alright, so they kind of cleaned up nicely. If you remember from the last video, this is our favorite. This is our favorite. This is our favorite because we just have a sine of x on the bottom, so it's going to clean up the nicest. Alright? It's most simplified in the bottom. Now, we do need to do a little bit of review, especially because now, today, we're going to be giving you the full angle, and you're going to have to be working for the half angle. So hopefully you guys remember that if your full angle is in, and I'm going to write full, if your full angle is in quadrant 1 or quadrant 2, well then the half angle is going to have to be in quadrant 1. And if you do a little math here, you know that quadrant 1 and quadrant 2 is 0 to 180. And when you take half of 0 to 180, you get 0 to 90, which is quadrant 1. Alright? Well, what about when you have quadrant 3 and quadrant 4? That's just going to be quadrant 2. And how do I know that? Well, because quadrant 3 and quadrant 4 is 180 to 360. And when I take half of that, I get 90 to 180, which is quadrant 2. And 0 to 90 is quadrant 1. Alright? So now in this next section, this should be our final little section of prep work that we need before we move on and try some of these problems. If we have alpha that's in quadrant 2, alright, So again, if I give you alpha, that means that that's the full angle. Full angle. So my full angle is somewhere in quadrant 2. This is full. Which means my half then is where? Somewhere in quadrant 1. I'm not exactly sure where. But I know that my half will be somewhere in quadrant 1. And that's really important because it matters where our half angle is for finding the sign of sine, cosine, tangent. And by sine, I mean positive, negative. All right? Right? We need to know whether it's positive or negative because all of our formulas ask for positive or negative. So we know that because this half angle turns out to be in quadrant 1, well then the sine's going to have to be positive, the cosine's going to have to be positive, and the tangent, of course, will be positive. Hopefully that makes sense. That should be the same stuff that we've been doing. Now, if our full angle is in quadrant 4, something like this, well then we know our half angle is actually going to be somewhere in quadrant 2. And that matters because now when we take a look, well, sine of the half angle, that'll still be positive, right? Because I'm going up, positive in the y direction. But now my cosine will be negative, and then of course my tangent will also have to be negative. Okay? Okay. So now that we kind of have reviewed our formulas, and we have some better understanding of how the full angles and half angles work, we're ready to start. Okay, so number 3 here. Alright, here we go. So, I know that the sine of my full angle is negative 3/5, and I know that my full angle is in quadrant 3. So when I draw my sketch of my full angle, I can draw in quadrant 3, something like this. I also know that sine is opposite. Sorry, I need to put my alpha in there. I know that sine is opposite over hypotenuse, so negative 3, positive 5. And then we should be able to know using our Pythagorean triples that my last side is negative 4. And this is the important thing, guys, and this is what I guess makes this abstract, is that I'm giving you a ratio instead of an angle. So you're going to have to work a little bit backwards to get to the place where you need to be. Alright? So now I have all my information about the full angle, and I can plug in cosines or sines or tangents, whatever I need. It's also a really good idea to understand where your half angle is going to be. And again, we need that because that is going to dictate the sign of those square root bars in our formulas. So because my angle is in quadrant 3, I know when I take half of it, oh, that's probably going to be, I don't know, maybe something like that. Yeah, that looks good. And so why do I care about that? Because now I know that my cosine, because my half angle is going to be in quadrant 2, I know my cosine is going to have to be negative, my sine will have to be positive, and my tangent is going to have to be negative. And this is good information to have before you start, because then you can use it to help check in a little bit. Alright, here we go. It's asking me to find the cosine of alpha over 2 first, or cosine of a half angle. So, cosine alpha over 2. Well, I know that the formula is going to be plus minus square root 1 plus cosine of full alpha all over 2. Well, I can start to plug some things in. I also can make a decision on my sine. I knew that cosine of the half angle has to be negative, so I have to carry a negative. I also know that I need to plug in cosine alpha. Well, cosine alpha I can get from my original sketch. It's negative 4/5. So I plug it in. And then that's all over 2. And now, guys, this just turns into all that nasty fraction work. I know you don't like it. I get it. But it's doable. And you guys are strong students, so we need to practice this. We need to get better with our fractions. So I turned my 1 into a 5 over 5 because that should allow me to now, let's see here. I'm going to go this way. So now I have negative square root, well 5 minus 4 is just a 1 over 5 then, and this is still all over 2. Now if you remember from yesterday's video, instead of dividing by 2, I think it's going to be easier to do what? Multiply by half. So I'm going to get rid of this division, and I'm going to multiply by 1/2 instead. Because now, as I'm going to kind of come back over here now, guys. I now know that I should have the negative square root of 1/10. Okay, not quite done. 1 is a perfect square. So the last thing that I would really want is I would want to see negative 1 over square root 10. For those of you guys that do like to rationalize and just won't stop, then negative root 10 over 10. All right? I'm not even boxing that, but just so you know that that is also a viable option. All right. I'm going to change colors here. We're going to move on to sine. I'm going to come over here for sine, guys, just because I want to save some space. I know that sine of alpha is supposed to be plus or minus the square root of 1 minus cosine alpha over 2. All right, well, we should have an idea of what to do here. We know that our sine is going to be positive, so I know I'm just going to use positive square root, and I already know that the cosine is negative 4/5, so 1 minus negative 4/5 all over 2. Once again, I'm going to change my 1 into a 5 over 5. And I'm going to start cleaning this up. Okay, so I have square root of, well, 5 minus negative 4, so this is now 9/5 all over 2. And just like what we did on the other one, instead of dividing by 2, I'm going to multiply by 1/2. So this should become the square root of 9/10. Please, 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 please make sure that you keep track and I guess just make sure that you're taking square roots when you can, because 9 is a perfect square. So 3 over root 10. Positive 3 over root 10. All right? So, again, for those of you that refuse to stop rationalizing, there you go, 3 root 10 over 10. Okay, now, that looks good. Tangent. We're going to go 1 minus cosine alpha all over sine alpha. All right? That's the formula we want to use. If you don't believe me, go back to the page before. Let's see here. Let's start plugging some stuff in. Well, this is 1 minus negative 4/5 all over sine is negative 3/5, so negative 3/5. Oh, this is going to be even easier, I think. I think we're already going to have common denominators, guys. Okay, so let's see here. 5 minus negative 4. I'm going to have 9/5 over negative 3/5. 5's cancel. 9 over negative 3 is negative 3. So that's good. I'm good with that. Again, guys, you can always use your trick. You can always do sine over cosine. If we do sine over cosine, if we say tangent alpha, tan of half angle is equal to sine half angle over cosine half angle, that should also work, right? We would have 3 over root 10 over negative 1 over root 10. And again, root 10's cancel. Once again, we get negative 3. So either way you do it, right, I'd probably say 1, 2. Either way you do it, you get the correct tangent. Now, number 4. This one's going to be slightly different. Please bear with me. Again, it's a lot of fraction work. It's a lot of you being comfortable using fractions and radicals. All right? You got to build up that skill. Let's see here. So I'm going to draw my full angle. Full angle. I know that I am in quadrant 4 because it tells me 3 pi over 2 to 2 pi. I also know that the tangent is negative root 2 over 2, so maybe something like this. Opposite is going to be the negative root 2. Adjacent is going to be the 2. Well, I need to work to get my hypotenuse, so let's do some Pythagorean theorem. C squared is equal to 2 squared plus negative root 2 squared, or c squared equals 4 plus negative root 2 times negative root 2, oh, just a 2. C squared equals 6. C equals square root 6. And I'll pause just a second so that you guys can catch up with me on that. But again, now that we have that third side, we can get the sines, the cosines, the tangents, whatever we need to fill out our formulas. One thing that we should always do, just so we have a good understanding of what we're looking for here, when I sketch my half angle, if my full was in quadrant 4, then my half is in quadrant 2. And then, of course, I know that my cosine will be negative, my sine will be positive, and my tangent will be negative. And now we're ready to get going. So, let's take a look here. Cosine alpha 2. Okay, we know that the cosine is going to be negative, so I'm going to just put my negative there now. I know that I have to do 1 plus cosine full angle over 2. And so the cosine here is going to have to be adjacent over hypotenuse, so 2 over root 6. And I'm just going to write that so we have it, because we're going to need it again. Cosine of alpha is 2 over root 6. Alright, let's take a look here. Let's plug that in. So now we have negative square root 1 plus 2 over root 6 all over 2. Well, we're going to need some common denominators here. So root 6 over root 6. Oh man, this is going to be messy, I think. If I keep going with this, I should have negative square root 6 plus 2 over root 6, and then that's still all over 2. Sorry for this. But again, instead of dividing by 2, I'm going to multiply by 1/2. Alright, so that should turn into, let's see here, negative square root 6 plus 2 all over 2 root 6. And I'm trying to think, am I good with that? Yeah, I'm good with that, guys, okay? I'm okay with that. We could rationalize this more if we wanted to. We could multiply top and bottom by root 6. But I am just going to say, for right now, if you can use the formulas properly, then that's what I'm looking for, okay? So I'm good with this right here. If you wanted to continue on, just because you like to rationalize denominators, you would need to multiply top and bottom by root 6, and then I think some other stuff would cancel out. But I am good with this for right now. Alright? Okay. Let's do the sine now. Sine's probably going to be pretty similar in regards to it being kind of sloppy and messy. But I do know that it's going to be positive, right? So I don't even need to put plus minus. I knew that my sine of the half angle had to be positive because it's in quadrant 2. So now when I do 1 minus cosine alpha all over 2, this should become, let's see here, 1 minus 2 over root 6 all over 2. Well, we're going to do the same thing. We're going to change this to root 6 over root 6. So now, let's see here. I'm going to have square root of root 6 minus 2 all over root 6 all over 2. but instead of dividing by 2, I'm going to multiply by 1/2. And so the final answer that I'm looking for here is going to be root 6 minus 2 all over 2 root 6. All right? And I am good with that. Whew. Ugly, ugly, ugly. At this point in time, I guess we have options. Just because these didn't clean up very nicely, guys, my thought here would be that it would probably be best to actually use our tangent formula. All right? And I know we did that up above, right? Tangent formula, we got it. We got a nice number here. Oh, you didn't see what I was pointing at. I showed you 2 ways to get tangent in this first problem. And obviously those 2 options are still viable for this last one. I'm just thinking, because these are so nasty, I think it would be really hard to use this method. Okay, I think we're going to go ahead and we're going to use our formula to finish off this video. All right, so tangent. I'm going to come over here. Oh, okay, so tangent, we like to use 1 minus cosine over sine. All right, well, a couple things. We need sine now. We need the sine. Sine here is going to be negative root 2 over root 6. And usually I would say to simplify this, guys, but I think I'd rather keep these both as denominators of root 6, because then I think the denominators will cancel in a couple of steps. So hopefully that makes sense, that I do not want you simplifying this sign. All right? Okay, so now when we plug in here, I know that I have 1 minus 2 over root 6 all over negative root 2 over root 6. And then, like normal, we will do a little bit of this, square root 6 over square root 6, which means this will clean up to square root 6 minus 2 over root 6, and then this is all over negative root 2 root 6 over root 6. All right, and now we get to do our favorite thing. We get to cancel those denominators. So I have root 6 minus 2 all over negative root 2. Guys, I think the only thing I really need from you here, again, I don't want you wasting your time rationalizing denominators. I do not like having negatives in the denominator, though, so I would probably do one of these, where I would say I'm going to divide every piece of the numerator by a negative 1, right? So I would actually have negative root 6 plus 2 all over root 2. And this is an answer that I would be okay with. All right? Okay. So there is our video on abstract half-angle identities. Hopefully it wasn't too bad. Again, I hope that you're just recognizing that it's the same formulas. I'm just delivering you information in a different way. Okay? Okay, we will practice in class. Have a good one.